Welcome back to the deep dive. Our mission today is, well, it's a deep dive into the physiology of performance, specifically for those of you who lift regularly but are always looking for an edge.
We're tackling a really big question in training today.
A huge one. Can you really get the same elite performance gains using very light weights as you can with, more traditional moderate lifting weights?
And we have a fantastic source to guide us. It's titled The Effects of Individualized Low and Moderate Load Circuit Training on Physical Performance, Hormonal Responses, and Hematological Adaptations in Resistance-Trained Men.
Wow, that's a mouthful.
It is. It's by Wuwen, Peng and a team of colleagues, published in the Journal of Sports Science and Medicine, Volume 25. Back in 2026.
That title tells you just how comprehensive this is. So the core question we're answering for you is this. Is low-load circuit training, let's call it LLCT, a legitimate substitute for moderate load circuit training, or MLCT?
And this is key. They're looking at gains in maximal strength, explosiveness, speed, and overall fitness in men who are already resistance trained.
Right. They aren't testing beginners here. These guys already know their way around a weight room.
Exactly. So to get the answer, the researchers took 32 resistance-trained men, average age around 20. They randomized them into 3 groups.
Okay, what were they?
You had your low-load group, the LLCT, then the moderate load, MLCT, and of course a non-training control group. The whole thing lasted for 8 pretty intense weeks with 2 supervised sessions per week.
Okay, let's unpack that training blueprint because the structure itself it's a masterclass in efficiency. It's how they could even compare these 2 approaches head to head.
It really is. Both groups did 4 total rounds of 5 non-stop compound exercises, multi-joint stuff.
And the exercise choice is critical here. They weren't wasting time on isolation movements.
No, not at all. They hit the biggest movers possible. We're talking barbell power cleans, behind-the-neck back squats, barbell bench press, the hex bar deadlift, and...
Let me guess, something to just gas you out completely.
burpees.
Yeah.
And that was the only body weight element, just to ensure total systemic fatigue.
So 5 really demanding exercises 4 times through. But the density, the work-to-rest ratio, that's the real story here, isn't it?
Oh, absolutely. It was a high-density protocol. 30 seconds of work, then immediately 30 seconds of rest for each exercise.
Wow.
And after they finished all 5 exercises, which took exactly 5 minutes, they got a 2-minute rest before the next round.
So if you do the math on that, the entire workout, this whole intense circuit, was just 24 minutes long.
Just 24 minutes, hitting cleans, squats, deadlifts, twice a week.
That is an incredibly tight schedule. Okay, so what was the critical difference, the external load?
And the difference was massive. The low-load group, the LLCT, they lifted at only 30% of their individual 1-rep max.
30%. That's forcing a huge number of reps.
A very high number. They were aiming for something like 20 to 24 reps in that 30-second window.
And the other group?
The moderate load group, the MLCT, lifted at a much more traditional 70% of 1RM. They were targeting, a more classic 8 to 10 reps.
So you have a high-speed, high-volume group versus a high-tension, high-force group. Logically, the heavy lifting should feel harder, but did it?
And that's where the circuit structure just flips everything on its head. The internal load, which they measured with session RPE, it was comparable.
You're kidding. 30% felt the same as 70%.
The metabolic suffering was the same. The time was the cap, not the weight. Exactly. They were both pushing to the absolute limit of what they could handle in that 30-second window.
The low-load group actually did more total reps, about 8.3% more, but the RPE and total volume were considered equivalent.
Which sets up the perfect scientific comparison. Same
Right.
time, same perceived effort, but a totally different external stimulus.
Precisely.
Okay, let's get right to the payoff then. Maximal strength, the classic 1RM test. What happened with the back squat and the bench press?
For both lifts, both the low-load and the moderate-load groups showed really significant improvements. They just blew past the control group.
And this is where the aha moment comes in, right? The one that could redefine how people train. This is it. There was no significant difference in maximal strength gains between the 2 protocols.
None.
None. They were statistically equivalent. The low-load group got just as strong as the moderate-load group.
That is so counterintuitive. I mean, if you're training for max strength, you're putting 70–80% on the bar. How do you explain this equivalence?
The key seems to be adaptation through overlapping pathways. The total exposure was matched, remember?
Oh, right.
So the moderate load group was using that classic mechanical tension. Heavy weight, muscle strain, hypertrophy, you know the drill.
And the low-load group. Less tension, but way more speed and fatigue.
Exactly. That high-rep, high-speed stimulus is a massive driver for neural adaptations. We're talking greater motor unit recruitment, higher firing frequency, better coordination.
So both paths lead to the same destination.
They converge. Both of them increase the overall neural drive that lets you lift a heavier 1RM. The brain and muscles just get better at working together.
That makes sense. The neural groove gets deeper with that much repetition, as long as the effort is maximal. I did notice one weird detail, though.
Let me guess. The control group.
Yes. The control group got a little stronger on their squat. Why did the non-training group get stronger?
Well, the researchers suggest it's likely just familiarization from the testing itself. Even for trained guys, practicing a 1RM squat 3 times in 8 weeks, you refine your technique.
Just enough to see a small, measurable gain.
It just highlights how much that neural component really matters.
Okay, so let's move from pure strength to explosiveness. Lower limb power. They used the counter movement jump and the squat jump. Did the equivalents hold up?
It absolutely did. The results were basically a mirror image of the strength data.
Same story.
Same story. Both 30 groups improved their jump height way more than the controls, but neither the low load nor the moderate load group was better than the other.
So again, same outcome, but probably achieved through 2 different mechanical principles.
That's the takeaway. The moderate load training likely increased their peak force. You can push harder into the ground, you jump higher.
Makes sense.
Meanwhile, the low load group, with its speed focus, probably got more efficient. They optimized their stretch shortening cycle, improved their rate of force development.
So different mechanism, same result. A higher takeoff velocity.
You got it.
Now we get to practical athleticism, speed and agility. They used a 30-meter sprint and the 505 change of direction test.
For agility, the 505 test, we see that equivalence continue. Both the low load and moderate load groups significantly outperformed the controls.
But the straight line sprint, that was the one test where the tie was finally broken?
It was. For pure straight line speed over 30 meters, only the moderate load group showed a significant improvement compared to the control group.
So the LLCT group didn't get faster?
Not significantly faster than the controls, no.
That feels like the most important exception in the whole study, doesn't it? The heavy group won the sprint. Why? Why did the 70% stimulus give them an edge there?
It really comes down to the principle of specific transfer and the physics of sprinting.
Okay.
Sprint acceleration depends heavily on generating high horizontal maximal force. They call it F0. It's about putting a massive horizontal impulse into the ground.
And the heavier weights are just better at training that specific quality.
Exactly. While the low-load training improves the neural rate of firing, that 70% 1RM in the moderate circuit was just a superior stimulus for increasing the absolute capacity for that F0.
So if you're trying to steal a base, maybe the heavier weights in a circuit still give you that edge?
That's the application, yeah.
Yeah.
Now let's pivot to metabolic fitness, VO max and peak power.
Did the equivalents come back?
It did. Both groups showed significant increases in absolute peak power and in their VO max, both beating the control group, and again, no significant difference between the two.
So this tells us that for cardiorespiratory fitness, the specific weight, 30% versus 70%, doesn't matter nearly as much as just achieving a high-intensity density.
Precisely. The key factor is generating enough metabolic disturbance, that feeling of being completely gassed after 24 minutes. As long as the work is intense and continuous, the adaptations for VO max happen pretty similarly.
And on peak power, the authors noted they preferred the absolute measure over the relative one. Can you break that down for us?
For sure. Relative peak power is normalized to your body weight. So think of it this way. Say you gained 5 pounds of pure muscle over the 8 weeks.
Which is a great outcome.
A great outcome. Your power output shot up. But because you now have to divide that higher power by your new, heavier body weight, the math might say you didn't improve as much.
You actually get penalized by the calculation for getting bigger and stronger.
Right. And that's why the absolute number was the more reliable metric here.
Okay, this is where we move inside the body. Systemic signals. Let's start with hormones. Testosterone and cortisol.
Let's start with the stability factor. Cortisol, the main stress hormone, stayed stable across all groups.
Which is good news.
It's excellent news. It suggests that even with the intensity, both protocols had a healthy training to recovery balance. No signs of long-term overtraining.
And what about testosterone?
Here it gets interesting. Both training groups showed significant increases in their resting testosterone. Total testosterone, the low load group went up 19.5%, moderate load up 18.2%.
So pretty similar.
Very similar. However, when you compare them to the control group, only the moderate load group showed a significant between-group increase after the 8 weeks.
Okay, so the tension-focused group had a slight edge in boosting resting testosterone. Should we be chasing that?
Well, probably not as the main goal. The paper reminds us that changes in circulating T are often only weakly related to the final strength or muscle growth outcomes.
It's the local factors that matter more.
It is. The mechanical tension on the muscle, the volume, the progression, those are the real drivers. The higher key is maybe some indirect evidence of a slightly stronger systemic signal from the heavier load, but it didn't translate into better performance.
Let's move to the even more nuanced stuff, the hematological adaptations. What happened to their blood?
Here we found some really unique distinctions. The moderate load group was the only group to show a significant increase in hemoglobin.
Which is key for oxygen transport. So did their overall red blood cell count go up?
That's where it gets subtle. While hemoglobin went up, their hematocrit, the percentage of red blood cells by volume, did not change.
So what does that mean?
It suggests the increase in HB was probably matched by a concurrent expansion of plasma volume. Basically, your blood gets a bit more fluid, which is a classic adaptation for better conditioning and blood flow.
That is fascinating. What about those other markers, RDW and MCHC? They sound super technical.
Let's just call this a free bonus adaptation. Both training groups, low load and moderate load, saw their red cell distribution width, or RDW, go down, and their mean corpuscular hemoglobin concentration, MCHE, go up.
Okay, translate that for us. What does lower RDW and higher MCHC actually mean for me?
It means the quality of your red blood cells improved. Lower RDW means your red blood cells are more uniform in size, which is more efficient.
And higher MCHC?
That means they're better filled with hemoglobin. In simple terms, both protocols subtly improve the efficiency and oxygen carrying potential of every single red blood cell. It's a huge, hidden physiological perk that feeds right into those VO max gains we saw.
So let's step back and look at the whole picture. Strength, power, agility, fitness, all these internal markers. What is the single biggest finding for someone trying to optimize their training?
The major finding is just undeniable. For almost every single performance outcome they measured, the low-load circuit training at 30% 1RM was just as effective as the moderate-load circuit at 70% 1RM.
Which means that low-load circuit training demonstrated just incredible mechanical efficiency.
Exactly. It achieved equivalent performance improvements while using way less external load. And that is a huge practical takeaway for longevity.
For sure. If you have a cranky shoulder or a sensitive knee,
You can back off the maximal weight entirely. You can lift light and still maintain or even improve your max strength, your power, and your metabolic fitness. It's a game changer for recovery or when you need to avoid injury.
of course, we should acknowledge the study's limitations.
Yes, definitely. The researchers note the sample size was pretty small, so that limits the power to detect maybe some minor differences. It was also limited to resistance-trained men.
And a big one, they didn't adjust the loads mid-study.
Right. They stuck to that 30% or 70% for the full 8 weeks. If they'd been able to progress the load as they got stronger, their potential might have been even higher.
Okay, so here is the final provocative thought for you to take away as you plan your next workout. Given that the low-load training was amazing for metabolic conditioning and red blood cell quality,
While the moderate load training gave that unique edge in straight-line speed and hormonal signaling,
how might a periodized program, one that strategically alternates between low-load days for metabolic focus and moderate load days for tension focus, how can that maximize both your speed and your strength at the same time without ever hitting a plateau?
and to really dig into the data on this, to see all the numbers and the full methodology, we really encourage you to read the original article. It's The Effects of Individualized Low and Moderate Load Circuit Training on Physical Performance, Hormonal Responses, and Hematological Adaptations in Resistance-Trained Men.
Knowledge is best when it's understood and then applied. Thanks for tuning into this deep dive. Make sure you follow the channel and turn on your notifications so you don't miss our next breakdown of cutting-edge research.
We'll see you next